Hi everyone. So this is another video in the Roundtable Lab series. This, like the other ones, is optional. You should be watching this if you're not really sure what you're doing or if you don't have the materials that you need. And you're welcome to watch this video and then go do your own experiment, or you're welcome to watch this video and use the data from my experiment as I walk through it. Before you move forward in this video, you should have already completed questions 6 and 7 on your lab report. So if you haven't done that yet, go ahead and pause this video and complete those questions. Where it says your first experiment, if you watch this video and use that data, you're talking about the experiment that I did in the video, okay? So go ahead and pause and get those questions done if you have not yet. All right, so hopefully you have 6 and 7 done by this point. I'm going to talk a little bit about my response to 7, or a possible response to 7. There's no wrong answer here. There are a lot of different answers that you could put for both 6 and 7. So please don't go back and change your answer to look more like mine. Yours is probably fine. So I'm thinking about my first experiment. I'm going to pull up that data. The guiding question again is, what material should be or would be best for a container to keep drinks hot or cold? So in my last experiment, I tested how these different containers would keep a drink hot. And just looking over this data, I want to remember what happened. Okay, so the drink that stayed the warmest, or the water that stayed the warmest, was in the coffee mug. That kind of makes sense. It's designed for that, right? And then also the plastic cup did stay pretty warm. The glass and the metal cups both got much closer. Oh, especially if I look at the final temperature here. The glass and the metal got way closer to reaching equilibrium with the room. So that makes me think right now that the metal and the glass cups are probably the worst if I'm trying to keep a drink hot. Now the question says I want to find a container to keep drinks hot or cold. And so I want to test to see if these materials work the same way with cold water. So I've decided that I'm going to do about the same experiment, but instead of starting with really hot water, I'm going to start with really cold water and see if the cups allow that water to reach the room equilibrium, or equilibrium with the room, at different times, just like they did for the hot water. So in your Roundtable Lab report, I didn't actually make a space for a second procedure. I probably should have. Let's add that in here. This is not required, but I think it's helpful just to stay organized. So I'm going to mostly copy and paste my old procedure because that was a pretty good procedure. Oh, whoops, but I want it to be. All right, but let's read through this. There's some stuff that's wrong here. I don't want hot water, I want cold water. I have some water in the freezer right now that I'm trying to get as close to freezing as possible, so as close to 0 degrees Celsius as possible. I want to measure and record the original temperature, or the starting temperature of the water. I'm going to pour 1 cup of cold water into each of my containers, start a stopwatch and timer, measure the cup every minute for 10 minutes. I think I'm going to change that a little bit. So I'm looking at the temperature in this room that I'm in right now, and it's about 22 degrees Celsius. And my water is going to be at maybe like 5 degrees Celsius or something when I start. And so there's not actually that much room for it to get warmer. Like, it will get warmer over time probably, but it's going to take a little bit longer. So I am actually going to change this to measure the temperature of each cup every 2 minutes for 10 minutes. Let's leave it at that. We'll see how that goes. I might do another thing where I check the final temperature like 20 minutes later, if that seems like it might be necessary, and then clean up. Okay, cool. I'm also going to copy and paste my table because that will work pretty well. I'll change a couple of things, right? All right, here's the table. Maybe, yeah, there we go. I obviously have to clear out this data because that is not from this experiment. And then I'm going to start it at 0 minutes. I'm going to go 2, 4, 6, 8, 10. and then I'm going to get rid of these rows. You can do this in a couple of different ways. If you have trouble with actually making the table, please reach out to me. I'm happy to help you with that. Okay, cool. So my table is pretty ready to go. I'm going to wait a little bit longer for this water to get cold, so I'm going to pause the video here, and I will come back and get the experiment started. All right, I have the water in front of me. It actually did start to freeze, so that's good. It means it's pretty cold. I just measured the temperature. It is at 5 degrees Celsius. When it was in here, it was 5 degrees Celsius. Let's see. So I'm going to put that across each of these. 5 degrees Celsius, because that's what we're starting at for each cup. All right, and I have some ice cubes in here also trying to get it cold, but I don't want to include those in any of the cups because that will change the temperature over time. All right, have my stopwatch ready. Okay, so just to double check my procedure, I have all my materials. I recorded the starting temperature of the water. I'm pouring 1 cup of cold water into each of my containers. I got an ice cube in that one. We'll just pop it. All right, and I'm starting my stopwatch as soon as this one is done. And because I don't want this video to go on forever, I'm going to pause it and come back each time that I'm recording a temperature, so you won't see me doing the whole thing, but you'll have all that data, and hopefully that will still make sense. Okay, so the 2 minutes just passed, and I recorded the first set of temperatures. So in the metal cup, it was 7 degrees Celsius. In the glass, it was 8. In the plastic, it was 6. And in the coffee mug, it was 6. So now I'm just waiting on 4 minutes. All right, so after 4 minutes, nothing had changed in any of them. They were still 7 in the metal cup, 8 in the glass cup, 6 in the plastic cup, and 6 in the coffee mug. So this experiment might actually end up taking a bit longer. I'll come back with 6 minutes next. All right, at 6 minutes, the metal cup went up to 8, the glass cup went up to 9, the plastic cup went up to 7, and the coffee mug still stayed at 6. So I'm actually going to change a couple things. Since this is taking a long time for them to change, I am going to change this next one to 10 minutes, and then the next one to 14 minutes, and we'll see if stuff has changed much by then. All right, so at 10 minutes, they had changed a little bit. The metal cup went up to 9 degrees Celsius. The glass went up to 10 degrees Celsius. The plastic went up to 8 degrees Celsius. And the coffee mug went up to 7 degrees Celsius. So I'm going to check back in another 4 minutes. All right, after 14 minutes, the metal cup is up to 10, the glass cup is still at 10, the plastic cup is 8, and the coffee mug is 7. So I think from here, I'm going to let it sit for, let's say 16 minutes. So I'll put final temperature 30 minutes. And let's see where it ends up after that amount of time. I do think we have something of a pattern here already, but it is a pretty slow going process, so the pattern is not as clear as we might want it to be. So let's see what's happened after a total of 30 minutes. I will come back and check in on that. All right, everyone. So the final temperature after a total of 30 minutes, so 16 minutes after I stopped the timer before, the metal and glass cups were both at 14 degrees Celsius. The plastic cup was at 11 degrees Celsius, and the water in the coffee mug was 8 degrees Celsius. So that's good. After 30 minutes, it did start to separate a little bit, so it gives us a better idea of which one of these will keep a drink cold for longer. So now that we're done with this part of the lab, you should be starting to think about the guiding question again. So what material would be best for a container to keep drinks hot or cold? And actually, before we do that, if we're using this data, we really need to know what is the coffee mug made out of. It looks like it's metal. I think I said this is in class before. It really does look like metal, and definitely parts of it are metal, but there is probably something else happening in here, because if it were just metal, we would be seeing something similar to this, right? This is one that's just metal, and it rose in temperature really quickly, or it tried to reach equilibrium with the room more than this one. So I'm going to leave a comment for myself here. Oops. And you might want to look into this. This is a Yeti mug. So what is a Yeti coffee mug made of? Because we'll need to include that in our report. We can't just say coffee mug because that's not actually a material. And obviously this is designed for this exact purpose. So we need to do a little bit more research on that. Okay, so go ahead and take a look at your data. This is all you need to do for this weekend. I want you to start thinking about the question, but you don't need to do the write-up again. You just did the experiment again. Stop here until Monday through 1. So you're all set from there. Don't need to turn it in or anything, and we will talk about the write-up in class on Monday.